Another application of binary matrices is dominance matrices. So you'll notice when we do some calculations in a moment that the actual calculating and the process involved is identical to communication matrices. The only difference is that our matrix represents different information. So the ones and the zeros in this case relate to who wins and who loses in a sporting competition. So if we're talking about one-step dominance, we're talking about someone or some team directly defeating another person or team. And two-step dominance is involved in this case, meaning you might not be able to directly defeat a team, but can defeat another team which is able to defeat that team. So it's sort of, again, a two-step sort of situation. And again, the D matrix in this case represents the one-step dominance, and if we square that matrix, D squared is the two-step dominance. And again, similar to communication, we find total dominance by calculating D plus D squared. So same idea. When we get to the end and we find the little total vector, the person or team that's got the highest score is the dominant team or person. So we can sort of rank teams in order from first to last on a ladder by using this method. So in this case, we are given 4 people, A, B, C and D, and they've played a pickleball competition. So everyone played everyone else, and then we've given a few results in a list there. So we are required here to construct the dominance network. So they don't give us the matrix this time, they tell us to create the network, and then from the network we're going to create the matrix. So we've got 4 teams, so we can just start our little network with A, B, C and D. Somewhere, it doesn't really matter where you write any of them. So A, B, C and D are our 4 people, or our 4 teams, and we are able to draw our arrows onto this network diagram based on that information on the left there. So we're told that A beats B and D. So when A beats B, for example, the arrow will point towards the loser. So A beats B means the arrow points from A to B. If A beats D, we'll also have a arrow in there pointing towards D. B beats C, so we can put an arrow in that way. C beats no one. So you can see already, we know C didn't beat B. We also know now that A must beat C because C beats no one. D also must beat C. And then we're told in the last point there that D beats C and B. So we've already got D beating C in there and D beats B in there. So now we've got our network drawn as to who beats who, and we can then use that network to construct the dominance matrix. So looking at your diagram there, obviously A, again, doesn't beat A, B doesn't beat B, C doesn't beat, and so on, and D doesn't beat D. So that leading diagonal again in a dominance matrix will always be all zeros, because it makes no sense for a team or a person to beat themselves. And we can get our information from our diagram where the ones go. So we can see A does beat B, so we put a 1 in that spot. A also beats C, and A also beats D. So the 1 is representing a win, the 0 is representing a loss in this case. So we're looking at the dominance matrix. The winner is on the left, the loser on the top, basically, is sort of how we're reading that. So if I'm looking at B to go across the row of B, when I look to see who B beats, the only person B beats is C. So I can have a 1 in that column there. B beats C and doesn't beat anybody else. We're told in the question C beats nobody, so we can put the zeros in there. And then from our network, if we sneak back up to the top again. We're looking for who D beats, and D beats B and C, not A. So we can put our ones and zeros in accordingly there. So we've now constructed, from our network diagram, we've been able to construct our dominance matrix. If we're going to calculate total dominance, it's the same thing as 1 and 2 step total communication matrix, so D plus D squared in this case. So on your calculator, you would type in your D matrix, you would then square your D matrix, and then you'd add the two together. So there's matrix D. I'm going to add it to matrix D squared, and there's my total dominance matrix. So once I've got my total dominance matrix, I would write that down. And I then can create my little total vector to see who's got the highest score, I suppose I'd call it, by calculating, again, the same as we do with the communication matrix, the total dominance score. So for example, A would have a total dominance score of 6, B has 1, C has 0, D has 3. So when I've got the total dominance scores, then I can rank in order. The highest score means the highest ranking on the list of teams. So in this case, A would be first because it's got the highest dominance, total dominance score. D would be second, B would be third, and C would be fourth on the ladder. So when it says calculate the total dominance matrix and then determine who won the competition, A wins the competition with a total dominance score of 6.